Homework 11, Polynomial Functions, Video 4. In this video, we'll discuss how to predict the end behavior of a polynomial function as a means for sketching its graph. Of course, if you already have the graph, it's easy to determine the end behavior. Both ends rise, both ends fall, left falls, right rises, or left rises and right falls. I always have to pause saying this because when I say left, I have to use my right hand because I'm facing the camera. But I digress. There are only 4 combinations of end behavior, which means there should be 4 sets of characteristics that should define those end behaviors. And there is, and it's something called the leading coefficient test, and it goes something like this. If the leading term of f of x is an x to the n. In other words, this is the highest power term in the polynomial and its coefficient. Then the end behavior is determined as follows. I'm going to make a 2x2 table, and on the top of the table we're going to categorize the leading coefficient as to whether it is positive or negative. So the leading coefficient is either positive, meaning greater than 0, or the leading coefficient is negative, meaning less than 0. The rows are going to be disaggregated by the degree, not whether it's positive or negative. Remember, the degree is always a whole number, so it can't be negative, but whether the degree is odd or even. So n is even, and n is odd. If we had unlimited time, I would get you to tell me these things, but since we don't, and since I'm monologuing instead of dialoguing, then I'll just tell you the end results. The best way to remember how to fill in the end behaviors in here is to have solid examples of each. For example, let's think of a polynomial function where the degree is even and the leading coefficient is positive. So I'm going to put a 1 in this first box and just come to the side, and let's make up a function whose highest power is even and whose leading coefficient is positive. Well, if I want the highest power to be even, I can put 2, 4, 6, or whatever, but let's choose the smallest even number we can, 2. And if I want the leading coefficient to be positive, then I need a number in front that's positive, and there already is. This is positive 1. Well, I know what this graph looks like. That's a parabola that opens up. Both ends rise. Let's fill in the box to the right of it, where the degree is even, but the leading coefficient is negative. We'll call this function g of x, just because I'm tired of saying f of x. So, can you think of a really simple polynomial function whose highest power is even, but whose leading coefficient is negative? Sure, take the previous one and stick a negative on it. That has an even degree, 2, and a negative leading coefficient, negative 1. And what does the graph of negative x squared look like? A parabola that opens down. So that is an example to remind you that under these conditions, both ends fall. Under normal circumstances, I would have you memorize this, but since on your test I am allowing you to use your notes, you need to understand it more than just memorize it. So let's fill out the bottom row, starting with this lower left corner, and we'll set up an example function of that. We'll call it h of x. And now we need a function whose degree is odd and whose leading coefficient is positive. So let's keep it simple. What's a good odd number I could use? I could use 1, but that's just going to be a line, and I want something with a little bit of curve to it. So let's use the next odd number, 3. coefficient to be positive, and it already is. I believe we've looked at the graph of x cubed before. It looks like a parabola, except the left end points down, and the right end points up, which means we can now categorize this type of combination, odd degree, positive leading coefficient, and say that the left falls and the right rises. And for the fourth and final combination, we need a function. We'll call this one j of x. I don't want to call it I of x because I has its own meaning. It's the square root of -1. But for an example of the fourth and final combination, we need a function whose degree is odd, so highest power is odd. We'll use 3 again. And whose leading coefficient is negative, so negative x cubed. I think most of you know that sticking a negative on a graph reflects it across the x-axis and turns it upside down. So it would be the mirror image of this graph if we turned it upside down. And in that graph, the left rises and the right falls. And this is called the leading coefficient test. By analyzing the degree, whether it's odd or even, and the leading coefficient, whether it's positive or negative, we can determine what both ends of the polynomial function's graph will do without having to graph it first. There are other gimmicks for memorizing this, but as long as you remember that the 2 questions you ask are, is the degree even or odd? You can't ask if the degree is positive or negative, it's never negative. And is the leading coefficient positive or negative? And then have examples of each combination to populate wrong class, to populate the end behaviors. So let's take a look at a few examples. For the most part, these are easy. There are a few examples where you have to do a little bit of work. For example, let's say I give you, let's call this one p of x. Why not? We'll say 5x to the 6th minus 8x to the 4th plus 7x to the 3rd. We'll put a minus 3 on the end, it won't matter. Because if the question is what's the end behavior, there's only one place we have to look, and that's at the leading term. The leading term is the term with the highest power, so we're going to analyze the 5x to the 6th. Again, you ask yourself 2 questions. Question number 1, is the degree even or odd? In this case, it's even. And is the leading coefficient positive or negative? In this case, it's positive. So, when the degree is even and the leading coefficient is positive, greater than 0, that means that both ends rise. So we could quickly conclude, therefore, both ends rise. So without doing a lick of work, aside this analysis, I already know that if I were to graph this, the left end would go up and the right end would go up. Now, what would happen in the middle? We don't know that yet. That's the middle behavior. This is the end behavior. We'll analyze the middle behavior in a moment. Let's take a look at another one. Warning, I'm going to try to trick you. We'll call this one q of x. And let's put up here, let's put 18x minus x to the 3rd power. Ask yourself, is the degree odd or even? Ask yourself if the leading coefficient is positive or negative. The degree is odd, but what about the leading coefficient? If you said the leading coefficient was positive, then you need to remember that the leading coefficient is not just the number in front. The leading coefficient is the coefficient in front of the x with the highest power. So the leading coefficient in the leading term is actually the negative x cubed. Remember, polynomials are sometimes written in different orders in terms of powers, but the highest power is where the leading term is, and therefore the degree and the leading coefficient. So, the degree is odd, and the leading coefficient is negative. So what does that mean about the end behavior? Well, when the degree is odd and the leading coefficient is negative, that means the left rises and the right falls. Left rises, right falls. Which means, without actually graphing it yet, I already know that the left end is going to rise and the right end is going to fall. What happens in the middle? Probably something like that. I say probably because I also know that this can turn up to 2 times because the degree was 3. Just like this one can turn up to 5 times because the degree was 6. Doesn't mean it would turn 5 times, doesn't mean this one would turn 2 times. It just means it could. Let me see how long this video is. I want to do a third example. Ooh, we've already crossed the 10-minute mark. I'm going to do one more example of end behavior in the next video.